Okay, we're in section, I guess, 2.1, complex numbers. Complex numbers. And we begin with the imaginary unit. So basically this thing covers the case where you have a negative under the radical. Okay, so they define I to be the square root of -1. Okay. And then also we note that I squared is equal to -1. So basically that'll get rid of the square root. That's what you have. Okay. Right. So we expand the real numbers to the complex numbers by throwing this imaginary unit into the mix. And what does a complex number look like? So a plus bi. There's two parts to it. The a is the real part, okay? And then the b is the imaginary part. When you work with these things, it's best to work with the I as kind of a variable. Okay, so when you add these things together and stuff like that, you're going to want to collect like terms and that sort of thing. So let's look at the operations you could do with complex numbers. And so we'll begin with the addition and subtraction. So in general, just operations. And again, we begin with adding and subtracting. And again, the concept is combine like terms. So let's look at number 2. And they'll make a big deal with the parentheses. You can kind of just ignore them. Okay. So you want to combine the real parts together. 4 plus -2 is 2, and then 6 i's minus 1 I is going to give you 5 I. Okay. So it's just like if you had -2 plus 6x plus 4 minus x. It's the exact same thing that you're doing here, except instead of x you have I. So -2 plus 4 is 2, and then 6 minus 1 is 5x. Same idea. Let's look at a subtraction case. I'll have 7 minus -9 plus 2i minus 17 minus I. Okay. So when we subtract these numbers, we have to be considerate of the distribution of this negative. So we'll have 7 plus 9 minus 2i minus 17 plus I. So add the real parts together. 7 plus 9 is 16. Minus 17 is -1. And then minus 2 i's plus 1 i's is minus 1 I. So it should end with, unless I made a mistake, which I may have done so, but I copied it wrong. So it's like number 6, but not exactly. Okay, so that's right. Multiplication then is kind of the same deal, except you can simplify I squared, right? So just remember, if you have an I squared resulting, so in other words I times I, that's going to be equal to your -1 from the definition above. Okay, so I squared, which is I times I, which is -1, and then you take this and then reduce any power of I. I cubed will be I times I, which is just then I times -1. So this would be -I. I to the 4th then is I times -I, which will be -1, which is 1. And then I to the fifth will just be I all over again. Okay, so I to the fifth is just equal to I. So there's really no need to use exponents with these imaginary numbers. Okay. Let's look at them multiplying these things together. And my light doesn't fall over. So I have, for example, number 10, negative 8i times 2i minus 7. Okay? So you're going to distribute and multiply together the i's just like you would with variables. So if you had, for instance, 8x times 2x minus 7, negative 8 times 2 is negative 16. X times x will give you x squared. And then 8 times 7 is 56. Okay, so it's the same idea with the imaginary numbers. So this is kind of just in the background. This is how we want to think of it. This times this, you get negative 16i squared. And then this times this, you'll get plus 56. Okay. So we can reduce the I squared. So from before where I was saying I squared is really the same as negative 1. And then plus, and I lost the I over here, so you also need an I. So I lost the X over here, you also need an X. So right, we have 56I, and then negatives times negative is positive 16, and then plus 56I, and it's good to go. So that, I mean, this is a single term, kind of like times a binomial. We want to look at what's, basically like two binomials being multiplied together when you have two complex numbers and the, okay, so negative 3 plus 9i. And what is this, right? Yeah, you can guess. It begins with F, so it's FOIL, right? First, outer, inner, last. 8 times negative 3 is negative 24. Those are our firsts. The outer, 8 times 9 is 72i. Your inner, negative times a negative is plus 12i. And then finally your last, negative 4 times 9 is negative 36. And then I times I is I squared. Okay, we'll simplify then, combine any constants. Right now all we have is 24. Combine your imaginary numbers together. That'll be 84i. And then minus 36i squared. I squared will replace with negative 1. Okay. So we'll have negative 24 plus 84i plus 36. And what's next? Combine the real parts together. And what is that? 112, I think. So plus 84. I don't feel like adding today. Let's do one more of those, and this is kind of foreshadowing the world to come. You have negative 7 minus I times negative 7 plus I. Okay. So again, it's first, outer, inner, last, but these are special, and they're going to be, we'll call them next conjugates, and we use them in division. Okay. So they're exactly the same except that middle operation. Here it's negative and here it's positive. Okay. So negative times negative 7 is positive 49. Those are our firsts. And then our outer, minus 7i. And then our inner, that will be negative times negative plus 7i. And last, negative I squared. Okay. So you got 49. The two middle terms are additive opposites, so they're gone. And then minus I squared, which is the same as minus negative 1. So I squared again. So the cool thing about this is the imaginary part goes away. You're just left with a real number. So we'll use that in division to simplify our division problem. So this is part C. And we use what we just saw in that problem, the conjugates, okay, to find our answer in this complex form. So Let's go ahead and look at it. So 22, we're dividing the real number 3 by the complex number 4 plus I. Okay, and you don't do long division here. It's not necessary. All you have to do is multiply top and bottom by the conjugate. So we'll have 3 all over 4 plus I, and you multiply top and bottom by 4 minus I. Okay. So in the numerator, we have some distribution to take care of. So 3 times 4 is 12, minus 3 times I is 3I. And that's all over first, outer, inner, last, and the bottom. So you get first 16, outer, minus 4I, inner, plus 4I, and then last we have minus -1. Okay. Or if you'd rather, minus I squared, but that'll just be minus -1. Okay. So we'll have 12 minus 3I, and then that's all over apparently 16 plus 1. So that'll be 12 minus 3I over 17. Okay, and our goal is to get it in the form A plus BI. You want to separate the real part and the imaginary part. Okay, so that's the spiel. So how do I do that? Well, you're gonna go ahead and what do they call that? Butterfly, or some people like to call it filleting the fraction. And you get 12/17, which is the real part, minus 3/17 I, okay, which is the imaginary part. Okay, so it's not enough just to get here, and probably that was okay in previous classes in high school and stuff. That's not good enough for us. We want you to go all the way and put it into this complex form. Okay. So let's look at another one. 28. So 28, we officially divide two complex numbers together, or by each other. So 3 minus 4I, and then 4 plus 3I. Okay. So again, it's not long division, right? You want to do conjugates. So I'll have 3 minus 4I in the numerator, all over 4 plus 3I in the denominator, and I'm multiplying top and bottom by, guess what? 4 minus 3I. Okay. So in the top we got some FOILization to do. So 12 outer minus 9I, inner minus 16I, and then last plus 12I squared. And that's all over. So first we have 16 outer minus 12I, inner plus 12I, and then last minus 9I squared. Okay. Simplify the heck out of this stuff. So I have in the numerator 12 minus 25I plus 12 times -1. I squared is -1. And the denominator, you shouldn't have any imaginary terms left, right? So 16 minus 9I squared is -1. And then 12, this will end up being -12. So, oh wow, those cancel out, really? That seems too good to be true. Negative 25I downstairs, I'm just left with 16 plus 9. So it looks like we don't have a real part this time. So I'm starting to stutter. Negative 25I all over 25, which will be -I. So the 25's canceled. Okay, so that's that. The next part we want, there's some, you deal with roots when you're simplifying, especially in the quadratic formula. You may get a square root of a negative, and we have to be able to simplify that. So section 4 is going to help you there. We're talking roots of negatives. Okay. And the deal is you kind of march the negative out the back door. I like the book will probably put the I in front, but I like to put it in the back because I'm marching out all the perfect squares into the front. So you end up with square root b times square root -1, square root property, and then square root of b times basically I. Okay. There's a mild warning along the way here. It's a bit of weirdness that we need to worry about. If you have radical negative 25 times radical negative 4, they want you to march out the i's first. Okay, so what will that look like? It'll be square root 25i times square root 4i, right? And then you have then you can multiply out the roots. You get square root 100, and then you can multiply out the i's to I squared. And at the end of the day, that would be 10 times negative 1, which is negative 10, right? Whoops, I went off the page there. Whoops, and there goes my light. Right, so how do I, what's the warning? Well, there's a wrong way to do this, right? So if you did negative 25 root negative 25 times root negative 4, and then multiplied out negative 25 times negative 4, and negative times a negative is positive 100. Square root of 100 is positive 10. So you see you get two different answers here, and the answer we want is this first one. We don't want to do this. Okay? So the moral of the story is to march out your imaginary units first before multiplying. Okay, so let's look at some problems. So number 30, we're just, simplifying these things. So square root negative 81 minus square root negative 144. Okay, so square root negative 81, you want to march out the I, so you get square root 81i, and then minus square root 144i. Okay. Square root 81 is 9, so you got 9i minus square root 144 is 12i. And then these guys are like terms, so you can add them together or whatever. 9 minus 12 is negative 3-ish. So we get negative 3i, and that would be that. Let's look at a couple more. So all kinds of examples for us to play around with here. Number 34, we have negative 5 minus square root negative 9 squared. So you want to FOIL this. You don't want to distribute that square. That ain't working here, right? So you get negative 5 minus square root negative 9 times negative 5 minus square root negative 9. Okay. So FOIL, negative 5 times negative 5 is 25. Well, even before we FOIL, we can go ahead and march those i's. So that was my advice. So let's take my advice. Negative 5 minus square root 9i times negative 5 minus square root 9i. Oh, and we could simplify that, right? So that's just negative 5 minus 3i, and then negative 5 minus 3i. Yeah, should have just done that in the first step, right? Bummer. FOIL, so you get negative times the negative 5 is 25. That's the first, and then the outer plus 15i, the inner plus 15i, and then the last plus 9i squared. Okay. Let's go ahead and simplify that. 25 plus 30i plus 9i squared is negative 1. Okay. So 25, and this will be a minus 9. 25 minus 9 is 16, and then plus 30i, and that's it. Let's look at another one, 34 or 40. This is headed towards, what we're headed towards is the quadratic formula, right? So you'll get an expression like you see in problem 40, and you need to be able to simplify it. So they're trying to take you one step at a time in the book. Negative 15 minus square root, and I'm going to go ahead and just march out the I, right, without even thinking. On top of that, I remember, 18 has a perfect square as a factor, so negative 15 minus square root 9 times 2i all over 33, and then you can march the 9 out the front door. So negative 15 minus 3 radical 2i all over 33. And then if you want to, you can butterfly it. I've been trained to factor out any common factors and then reduce. What you don't want to do is kind of one of these things where you're crossing into a subtraction operation. Technically, you're not supposed to be canceling that way, and it always leads to trouble. I rarely see somebody do it correctly. So anyways, I'm going to factor out a 3 from the numerator all over 33, and then reduce it right there. You can do that. Okay. Maybe it's easier to butterfly it. I don't know. So anyways, I'm getting negative 5 minus radical 2i, and then it'll be all over 11. And then I'm going to go ahead, maybe I should just butterfly right off the bat. But now I'm going to butterfly it. So negative 5 elevenths minus radical 2 elevenths I. Okay. So that'll be useful once we get to the quadratic formula, which is coming up very, very soon. Let's look at number 44. Okay. Here's number 44. What do we have? So I have 3 times, sorry, it's, what is it? 3 times the square root of negative 7 times 2 times the square root of negative 8. Okay, so the warning from before applies here. You want to go ahead and march out the i's before you start fooling around. So you get 3 radical 7i times 2 radical 8i. Then you're going to multiply out stuff. So 3 times 2 is 6. Radical 7 times radical 8, radical 56 if you want, and then I squared, I times I. Radical 56 has a factor of a perfect square in there, right? So it has a perfect square of 4. So you can rewrite that as 4 times 14, sorry. And then I squared is just negative 1. March out the 4, so you get 6 times 2 times the radical 14 times the negative 1, and then multiply it out. It's negative 12 radical 14. Okay, so finally now we see the quadratic formula. So we're solving these quadratics. You set them equal to 0, so I have x squared minus 2x plus 17. It's all set up for me and ready to go. If you need to identify a, b, and c for your formula, a is 1, b is negative 2, and c is 17. Okay. And then we're plopping it into our formula. So how did that go? X equals negative b. So negative 2 is 2, plus or minus square root of b squared is 4. Minus 4 times a times c, all over 2 times a, which is just 2 times 1. Okay. Let's simplify it. So I'll have 2 plus or minus square root of, what's 17 times 4? 8, looks like 68. 4 minus 68, all over 2 times 1 is 2. So x equals, we don't want to write that again, just write equals. 2 plus or minus square root negative 64 all over 2. We can simplify now the radical, so march the imaginary out the back door. So you get radical 64i all over 2. That'll be 2 plus or minus 8i all over 2. Let's go ahead and butterfly this character. Okay, right off the bat. So you'd get 2 over 2 plus or minus 8 over 2i. And then, of course, that's just 1 plus or minus 4i for our solutions. Let's look at 48. Another one of these. 2x squared plus 2x plus 3 is equal to 0. If you need to, identify your a, b, and c. Plop it into your, got carried away there. X equals negative b, so negative 2 plus or minus square root of b squared, 4 minus 4 times a times c, all over 2 times a. And then begin the long, tedious process of simplification. Negative 2 plus or minus square root 4 minus 12 times 2 is 24, all over 4. That'll equal negative 2 plus or minus radical negative 20, all over 4. Okay. That'll equal, and then we want to start simplifying. Negative 2 plus or minus square root of 20i, all over 4. Okay. And then that'll equal, we'll go ahead and pull out the perfect squares, right? So we got 4 times 5i all over 4. Sort of running out of room. That'll be negative 2 plus or minus 2 radical 5 all over 4. And then I'll butterfly it. So I get negative 2/4 plus or minus 2, I lost my I somewhere, 2 radical 5 all over 4i. And then simplifying, negative 1/2 plus or minus radical 5/2 I. And that'll be it. All right, so that will finish up sort of the mechanics of the operations of complex numbers. And next time we'll look more at quadratic functions. Okay.